module, Module 3, where we will cover all the building blocks, or if you wish, the foundational services. And those could be grouped into 6 categories: compute, storage, networking, database, security, and management. Those are the categories that we will cover today. So let's begin with compute. Well, the first compute service is Amazon Elastic Compute Cloud, or EC2. This is where it comes from. All right. Those are virtual machines. Simple virtual machines. We didn't reinvent the wheel. We just made it our own. We improved it. But we're using virtualization. Same as you're familiar with, that you've been using for maybe decades now. So we've got physical, just for those of you who are less familiar with virtualization, let me explain to you a bit what it is, how it works. So we've got a physical server here running in one of AWS's data center. So that physical server has hardware, physical hardware. On top of that hardware, what we do, we install a specific operating system that provides us with virtualization capability. So basically, that operating system allows us to virtualize that physical hardware into virtual hardware and run virtual machines. That type of operating system in the virtualization world is called an hypervisor. So we install an hypervisor. VMware is an hypervisor. Hyper-V is an hypervisor. So we've got our own hypervisor. Anyone knows which hypervisor we use? Anyone happens to know which hypervisor we use? Good question. Aha. Let me give it to you. We used to use Zen. However, now we came up with our homegrown hypervisor. Our homegrown hypervisor is called Nitro. You can read on that. It is pretty powerful for several reasons. So it's more performant, mostly. So that's our hypervisor. That layer is kind of an operating system that runs on our physical server that allows us to run virtual machines. And our virtual machines are what we call EC2 instances. So that virtual machine has a virtual hardware layer. So basically virtual CPUs, memory, networking resources, things like that. All right. So that virtual hardware layer, you will install on top of it an operating system. In our case, we do support several Linux flavors. We support several Windows versions, and we do support even Mac OS now. Pretty cool. So you will install your operating system. And then on top of that, you will install applications. All right. And in order to do that, you will use what we call an Amazon machine image, or if you wish, an AMI. So the AMI is basically a template that includes the operating system and optionally some applications. So for example, you could take an AMI from our quick start that includes Windows. You could take an AMI that includes Windows and Microsoft SQL altogether. When you do so, when you take an AMI from our quick start, by the way, in this example here, I talked about Windows and SQL. If I took an AMI that includes that, it means that in my subscription price, they will include the licenses. I don't need to bring over any licenses for Microsoft, Windows, and for SQL in that case, because it's part of my AMI, it's part of my subscription. And from that AMI, from that template, you can actually create your own. So you can start with an existing one, including, let's say, SQL. And on top of that, add maybe optional software that you would like to be part of your main image, and then save that as a custom AMI that you can reuse. That will show up under My AMIs in the GUI. All right? So you can create your own AMIs. So that will dictate the operating system that you deploy, as well as maybe some applications. That virtual machine has some resources that you will dictate. So number of virtual CPUs, number of memory, the amount of memory, and so on and so forth. But that physical server actually can run a lot more than that because it has a lot of physical resources. So this is why a single server runs several virtual machines. Of course, several of them. They could be yours, but they could also be other customers. But it's secure. There is absolutely no way that customer B can access machines from customer A. Impossible, right? It is secure. All right. Now, my question, those virtual machines, does AWS has any visibility into the operating system and the applications that are installed on it? Paul says no. Do you guys agree? No. Martin? Mohammed? No as well. Alexander? No. So you all seem to agree with no, and hopefully no. And you guys are correct. Yes, because hopefully, Colin, as you mentioned, hopefully no, because that would be a breach of compliance. That would mean that AWS has access to your data. So that's unacceptable. So this is why when you connect to a virtual machine, there is only one way to connect to it. It's by using the two secret keys. There is one that is public and managed and stored by AWS. And there's another one that is given to you when you launch a virtual machine. And there's only one copy of that key, and it's the one you download, the one you get. You got to save it somewhere securely, properly, because AWS has no copies, any copy of that key. So AWS cannot connect to your virtual machine. So if someone from AWS support calls you and say, listen, I'm from AWS support, and there seems to be a problem with your EC2 instance. I would like to connect to it and troubleshoot the problem. Could you please give me your secret key? Hang up. It's not AWS. It is someone trying to hack your account. Absolutely, Paul. That sounds legit, right? So we do not have access to that, which means, let's say you took an AMI that included Windows and SQL. Those licenses are provided part of your subscription. But then any additional software that you install on that virtual machine is your responsibility. You got to bring over your license. It's your problem. We do not monitor that. We don't have visibility into that. We don't care. All right? It's your responsibility. Remember the shared model. That's one of your responsibility as a customer. Which means you've got complete control of your operating system with all the administrative accounts, and you're responsible for the installed applications. And those machines, you'll see that they come in different flavors. So we can actually, when we launch an EC2 instance, auditors access to customer EC2 instances. That is a very good question. That would be the customer's responsibility. So, for example, customer could create a temporary account that would allow and use what we call a role. We'll explain that a bit, but it's covered in greater depth in the Cloud Practitioner Essentials course. But you would use a role for that, and that auditor would assume that role, providing access to the virtual machines. All right. So that's one way to do it. But yes, it is possible, but that's the responsibility of the customer, to answer your question. Yes, so when you launch an EC2 instance, you will need to pick an instance type or a family if you wish. What is it exactly? Well, it's the same as when you go to a store and you try to buy a new laptop. The person there is gonna ask you two questions. First, they're gonna ask you, well, what do you intend to do with it? And the second question, most likely, will be, what's your budget? Because this will dictate what they will recommend to you to use. So if I was to say, well, this is for my father who's 75, barely browses the internet here and there, Well, they will probably recommend a very small laptop, not a lot of resources, because it doesn't need a lot of resources. And also the price probably will be cheap. But if I was to say, no, that's for my son who plays all those heavy games, he's an avid gamer, well, in that case, they'll probably recommend a much bigger machine, with more resources, more CPUs, more RAM, maybe a dedicated graphic card. But that laptop will probably cost me a lot more, of course, because I need those resources. So it's the same here when you pick an instance type. There are several of them, and they have different characteristics. So let's begin with the very first one, general purpose. As the name implies, this one has a well-balanced set of resources, memory, CPU, network bandwidth, as well as disk performances. All right, so it's a well-balanced set of resources. So that's ideal for most workloads. Most workloads. If you don't know what to choose, start with general purpose. Most likely that's going to fit your needs. But there are some cases, some scenarios where you need something a bit more specific based on your needs. So for general purpose, as you can see, they start with T's and M's for most of them, A as well. And then there's compute optimized. Compute optimized provides more computing resources. So that is ideal for those compute intensive workloads, such as batch processing. So if you've got a lot of batch processing in your workload, compute optimized is your best bet for that. We've got memory optimized, which provides more memory resources for memory intensive workloads such as databases. You know how databases are, right? You just install Microsoft SQL, you're not doing anything with that database. It's brand new. And already the SQL process eats up more than half of the memory, the available memory. Well, there's a reason for that. It's built that way because it tries to leverage all the memory available, because it'll cache those pieces that you query frequently. So on subsequent queries, the response time will be a lot more quicker because all the information will be preloaded into memory. Well, if you're running an IN database, memory optimized is a very good fit for that. Accelerated computing, to answer your question, Paul, accelerated computing is an instance that leverages hardware accelerators, or if you wish, GPUs, to provide even more computing resources. So that's awesome for floating point calculations. That's awesome for heavy gaming servers. That is awesome for video streaming, where there's a lot of encoding and decoding going on. Accelerated computing is ideal for that. Storage optimized. This one provides better IOPS, or input output per second, from the disks. So that will be ideal for workloads that are sequentially writing a lot of data and then randomly reading from it. So good example, good use cases for that. Data warehouse applications. Very good use case for storage optimized. Or online transaction systems such as OLTPs. And yes, few questions here. So GPUs, I've explained that. So if you want to leverage GPUs, Matthew, you got to go with accelerated computing. Abhishek, what instance will Netflix use? Well, Netflix uses a lot of instance types because they have a lot of services that runs on AWS. So I don't want to get into that because I could spend a lot of time there. Natalia, what do you mean by customer can change instance types seamlessly? Well, let me explain. Let's say you started with general purpose, and you'll also see that on top of the family, you also got to choose a size for the virtual machine. At any given time, if you want, you can change the instance type and size. Or if you wish, you can scale up or scale down. Or if you wish, scale vertically. Now, that involves one important thing, a shutdown. You've got to shut down the instance, then you can choose a different type and size and power it on right away. And it's going to take just a couple minutes to power on, depending on what runs on that instance. But still, you need to do a shutdown. Just remember that. All right. Lucian, for database, wouldn't storage optimized be preferred in the year of memory optimized? It depends. It depends. In some cases, when you deal with a NoSQL database, absolutely. In that case, storage optimized would be better. But if you're dealing with a relational database or a SQL database, in this case, memory optimized is better. So it depends on the type of database you run, but you are correct. In some cases, it might be better to use storage optimized, especially with NoSQL databases. Yes, and we've got different CPUs available, by the way, Intel, AMD, ARM-based processors, as well as Graviton, which is our homegrown processor that provides 40% more computing capabilities for the same price, the same size. All right. So when you choose your instance type and family, you will need to choose an instance based on its name, and that's the naming pattern for our, here's my pen, for our EC2 instances. Let me explain how it works. First, you've got the letter. The letter dictates the family type you are using. So I don't know if you've got a graphic memory, but M is from which family type? Anyone remembers? Memory optimized? No. Memory optimized start with R. General purpose, absolutely. General purpose. So this means I'm currently choosing a general purpose type instance of the 6th generation. So the next number in line is actually the generation. So in this case here, it's of the 6th generation. But I could choose an older generation. So for example, I could go with an M5. Why would I like to go for an older generation? Anyone has a good use case for that? Going for an older generation. Good question. Matthew, absolutely. Legacy software, compatibility. Yes, so you're running a legacy application that does not support the newest generation? Well, too bad. Just go with an older generation. That's it. All right, so that's one reason. Colin, costs? And I like that question mark because you really are asking, isn't cost a good incentive? No, and I'll tell you why. It was my first reflex as well, by the way. So you're not alone out there, Colin, thinking about costs. I had the exact same reflex as you. Now, in most, if not all cases, AWS will always charge you less for the newest generation than the older generation. When I say less, it could be really less. It's going to cost you less, or it's going to cost you the same price. But let's take that example here. After the generation, there might be an attribute letter. Not all of them have, but some have an attribute letter. And G in this case here stands for our Graviton 2 processor, our homegrown processor, which is more performant. Which means if you were to take an instance of the 6th generation and an instance of the 5th generation of the same size, so 16x large, well, you're going to get here 40% more computing resources for the same price. So yes, they're charging the same, but you get more for your buck. So basically, you're saving money. So cost is rarely, if not never, an incentive to go for an older generation. Typically, it really is for not compliance, but compatibility reasons. All right, when you deal with legacy applications. I wanted to clarify that, Colin, because I knew that there were people out there thinking the same as you and I initially. Then, You've got the size. So in this case here, 16x large. So instance types can range from different size. So it could start with nano, micro, small, medium, large, extra large, 2x large, 4x large, 8x large, 16x large, and so on and so forth. Can even go, I think, up to 64x large, if not more than that. This will dictate the amount of resources that machine has. So on top of the family type and generation that you choose, you're going to choose the size that will dictate those resources. So in this example here, an M6G16X large means you'll receive 64 virtual CPUs, 256 gigs of memory, 25 gigabytes per second of network bandwidth, as well as some disk bandwidth as well. All right, so this will dictate those resources. All right. Before we get to the break, let me wrap up the EC2 instances by talking about the purchasing options. So, yes, when you subscribe to an instance, you can also choose a purchasing option. And this could lead to significant savings. So let me explain what those options are. First, the default is to use on-demand. On-demand is quite simple to understand. You're going to pay by the second. So you're going to be billed by the second. There's no commitment. So you can run it 71 minutes and you'll pay only for 71 minutes. You won't pay for more than that because you don't commit to anything. You pay only for what you use. If you don't know much about the workload, you don't know if it's a spiky workload, a stable workload, you don't have much information, well, start with on-demand. That's a very good starting point. And then let it run for a few months and then do some analysis and see if you cannot refine your purchasing options. And when you do that analysis, then you can start looking at, for example, systems that constantly run 24/7 all year long. So if you've got such systems, for example, your web servers, it's your web presence, so you want it to be up and running at all time. Well, those, if you know they will constantly run, you could go with a reserved instance, or if you wish, an RI. A reserved instance is what? Well, it's a commitment. So you will commit. It really is a commitment. Commitment of what? Commitment of a term. So 1 year or 3 years. It's not 1, 2, 3 years. It's 1 or 3 years. Yeah, but I need it for 2 years. Well, subscribe to 1 year and then renew. As simple as that. All right. And you commit as well to an instance type and size. So M5 large, for example. All right. And once you commit, that could lead up to 75% savings by doing so. So you're going to pay 1/4 of what you would pay on demand for the same instance just because you committed for a year to run it. What if you shut it down for a month? Well, it's a commitment. You'll still pay for it. You've committed to that. That's why we committed to give you 75% savings as well. So that's why there is a commitment. You'll still pay for it. But if you properly analyze your workload and you know there are servers that will constantly run, might as well reserve those. You're going to save a lot of money there. You're going to save a bundle there. But as you can see, you commit as well to an instance type. What if midterm you made a mistake and you would like to change your mind and go for another instance size? Well, you've committed. You cannot. There's another instance type as well that is a purchasing option that is in the Cloud Practitioner Essentials course. It's not here, I don't know why, which is called convertible RIs. Convertible RIs allows you to midterm or at any time during your term to go for a larger machine, but only a larger, not a smaller one. Go to a larger machine, and the price will be adjusted to the new size of that machine. But in that case, you're going to save between 55 to 65% as opposed to 75%. So you're going to save a bit less, but we allow you to change the instance size. But yet again, you still are stuck with that instance type. This is why I want to show you that other one here. So I'm going to skip Spot for now. And I'm going to go with Savings Plan, which I think will become more and more popular. I think at some point it will even surpass the reserved instances. What's Savings Plan? Well, with Savings Plan, it also is a commitment of 1 year or 3 years. So same thing here. However, you do not commit to an instance type and size. You commit to an amount of spending per hour. So for example, if you know for sure, you are certain that at any given point in time, you'll pay at least $5 an hour for your instances, because you're going to be running instances constantly, and the minimum number that you'll run will sum up to over $5. Well, in that case, you can commit to a savings plan. So which means if you commit for $5 an hour, what's going to happen is that the first $5 will be discounted up to 72%. That still is significant, 72% savings for that first $5. And if you happen to go over $5 and let's say you've spent $7 for 1 hour, well, the first 5 will be discounted, and then the second $2 will simply be charged at the on-demand price. So you're not stuck. You have all the flexibility you need. And we don't care about the instance types and size here, or the amount of machines you run. So you could change the instance type 10 times a day. We don't care. We just look at your spendings. But it is a commitment, which means what if for 1 hour you didn't spend $5, you spend $2? Well, you're going to be charged for 5. So again, you got to properly analyze your workload. So this is why I'm saying on-demand is often a good starting point. And then you do some trend analysis and you analyze. And then you can refine by going with another purchasing option. All right. There's also another one that I didn't cover yet, spot instances. What are spot instances? Well, for those, spot instances are pretty cool. Pretty cool. First, there's no commitment at all. And you will save up to 90%. You're going to pay 1/10 of what it costs at on-demand price for spot instances. That means we should use spot instances for everything, right? No. Because there is a huge caveat with spot instances. What is it? Anyone happens to know what the caveat is with spot instances? Good question. Rob, it is not guaranteed. Alicia, bidding, although they got rid of that bidding thing. But Lucian, it's not the storage that is not guaranteed. It actually is the instance itself. And let me explain why. You gotta be careful. Yes, your application can be stopped at any time. It can be interrupted. Absolutely. Let me explain why now. So as I mentioned, we've got several physical servers in a data center. So in a data center, we've got anywhere between 50,000 to 100,000 servers, right? But we've got a bunch of servers in that data center. So maybe some of those servers are in use at the moment. So they are running virtual machines. But maybe we've got a bunch of servers that are idle at the moment, doing nothing. But AWS still has to pay for the cooling, for the power of those physical servers. So instead of paying for those resources for nothing, AWS is more than willing to rent those resources, idle resources, at a heavily discounted price, 1/10. However, at any given time, if there's an increase for on-demand instances, reserved instances, or savings plan instances, and AWS needs those idle resources back, they will send you a 2 minutes warning. You can do a lot in 2 minutes. Can shut down the instance, you can snap the volumes, you can do a lot. Can all be scripted and automated. But at the end of that 2 minutes, AWS will terminate the instance, not shut it down, not hibernate it, terminate it, which means the instance is deleted. So as you can see, you cannot run all types of workloads on that. It has to be what we call a stateless workload, or a workload that can withstand interruptions. So let me give you an example. Let's say you've got an instance that is there to grab some videos from an S3 storage bucket and re-encode those videos in a different format and save it in the S3 bucket again. Well, what if at some point that instance gets terminated? Of course, the video it was currently processing will be lost. But what if you can then boot it back up when the resources are available and start over that video to pick up where it left off when it was terminated? So that's a perfect use case for that. Or you've got data in a database, maybe an RDS, and on a daily basis, you're running reports using that data. And those reports are generated through an EC2 instance, by an EC2 instance. What if one day you don't have those reports? Well, maybe you don't care. Maybe the next day you're going to run those reports and pick up where you left off. So that's another perfect use case for that type of EC2 instance spot, because you're going to save up to 90%. But as you can see, it's a workload that can withstand interruption in that case. That's important to understand. All right. All right, so we're going to take 5 minutes or 6 minutes, and then we'll get back to auto scaling, EC2 auto scaling, another pretty cool topic that I want to cover. So let me give you 6 minutes here, and then we'll resume. Talk to you soon. All right, we're back. Sorry, little technical difficulty. So you guys hear me? Awesome. All right, some questions before we resume. Somebody asked, hold on, I need to scroll up. Yes, so one of the question is from Lucien, and I think it's a great question. Will the spot instances on EC2 be turned on when the resources are available again? By default, they're not, because by default, those are being terminated, which means deleted, destroyed. However, you can make a request, a spot, persistent spot instance request. So when it's a persistent request, the difference is instead of terminating the instance, They will either hibernate it or shut it down, depending on what you choose, what you set. And then when the resources are available again, they will spin it up, spin it back up for you automatically. You don't need to spin it up yourself, all right? But for that, you need to make it a persistent request, all right? And I show that in the Cloud Practitioner Essentials course, which should be the next one in line in your learning path. So I do a lot of demos in that course. I typically do a lot of whiteboard sessions. In this course here, there are no whiteboard session nor demos because we're limited in time for what we have to cover, but it is done in the Cloud Practitioner Essentials course. Another question was, another possible use case is workloads that are only feasible at low compute prices. Well, agree to disagree, because even if you need to have low compute prices, if it is not a stateless workload that can withstand interruption, so for example, let's say on that instance, you are storing critical data. Keep in mind that it's going to be destroyed when they shut down the virtual machine if they need those resources back. So it's not all types of workloads, even those that are that require cheap costs to run, doesn't mean necessarily that it's still it is a good candidate. You really got to evaluate which type of workload it is to ensure it can withstand interruptions. And maybe leverage then the persistent spot request in this case. So those are options available for you. Very good questions. You guys are great. All right. Sorry. Let's get back here. Next topic, Amazon EC2 auto scaling. What is it exactly? What does it do? Let me explain that. By the way, how am I doing so far, guys? Is it okay with you? Do you like those ugly drawings over the slides, or would you rather have me stick to the slides? How do you like it so far? I want to make sure that you guys enjoy that session. All right, so Matthew, you'd like me to... Oh, yes. Pro for the... Okay. So we'll go with the ugly drawings then as well. Thank you. All right, so EC2 auto-scaling, what is it exactly? Let me explain. So let's say I've got an application that is made of 2 tiers. So let's say I've got my... let me grab my pen. So I've got my web servers, for example, and let's say I've got my backend servers, so my app/database servers. All right. So I could launch my resources, but then how do I adjust to the demand? So remember my online retail store example where I've got a website that is heavily used in December, but a lot less in January and February. So how do I adjust to the demand? Well, I could actually monitor my resources. And then when I see that they are heavily used, I can spin up additional instances. I could do that, definitely. But that means that I need to constantly monitor my resources, and then I need to react. What if I could automate the whole thing? Introducing EC2 auto scaling. That's exactly what it does. So basically, you're going to create auto scaling groups. So I could create an auto scaling group for my web servers. And then you define 3 parameters. You define the desired number of virtual machines, the minimum, and the maximum number of virtual machines. So I could say I desire 2, but the minimum is 1 and the maximum is 4, which means the system will apply that auto-scaling group, and when it applies it, it's going to launch the number of desired instances. So it's going to launch 2 machines. And then it's going to monitor the usage of those instances. And by default, AWS collects metrics about your EC2 instances every 5 minutes. Metrics such as the CPU usage, the network usage, or the number of connections, right? So what you could do, you could then adjust with the demand and say, let's say I monitor the CPU usage and it goes over a certain threshold, the system will notice and will therefore automatically launch a new instance and add it to the fleet. And if the demand keeps on increasing, it's going to spin up another one until it reaches the maximum number of instances. And then it's going to keep on monitoring those resources. And if the CPU usage goes down significantly because the demand is decreasing, system will notice and it will start automatically shutting down instances. It's going to shut down one instance. And if the demand keeps on decreasing, it'll then shut down another one and another one until it reaches the minimum number of machines that I've defined, that I've set. And in this case here, one at all time, because it's my web presence. I want it to be up and running at all time. So you adjust to the demand automatically. That's pretty cool. Pretty cool. You don't even have to monitor yourself and spin up instances. The system will adjust automatically. There's two ways to do that. There's, like I just explained here, which is called dynamic scaling, because it will adjust to the demand dynamically. So that's dynamic scaling. There's another one as well, which is scheduled. And in this case, it's a bit different. It's based on schedules that you define. So for example, you could say, well, that environment is for developers. And I know that they do not work on evenings. They do not work on weekends. So why running a full-fledged environment 24/7 when they're not really working out of business hours? So I could say, as soon as we reach 6 o'clock at night, bring the number of instances down to maybe one in case someone is doing a bit of overtime. And then on Monday morning, bring those back on, the entire fleet to meet the demand. And you can even combine those two together, by the way. So Lucian, we'll talk about load balancers in a minute. So what if 4 instances aren't enough? Do you get a notification that you need more so you can react? Well, Paul, to answer your question, not by default, but you can, absolutely. You can create an alarm to notify yourself. That's really easy. And I explained that in the CPE course, Cloud Practitioner Essentials course. I actually do a demo. I create an alert. But you are correct. You can create one to be notified. So absolutely. Yes, Christmas schedules. That's another very good use case. Absolutely, Mohammed. All right. And those auto scaling groups, cool thing is you can create as many as you need and they are independent from one another. So for example, you could create another auto scaling group, but this time for your backend servers. And they could have complete different settings than that group here because they are independent. The cool thing about ASGs as well is that it includes a health check mechanism built in. So for example, if one instance becomes unresponsive, the system will notice and will automatically kill it and bring another one to replace it. So it is self-healing. That's pretty cool because now you can see your EC2 instances as commodity compute resources. So if one does not work as expected, don't even bother troubleshooting it. Just kill it and spin up another one. Actually, the system will do it for you automatically. That's awesome. All right. So those are auto scaling groups. So you'll always pay for what you need. You don't pay for idle resources because it can scale back in, but you ensure to meet the demand because it's going to scale out whenever needed. All right. So auto scaling groups. Let me add another topic to that because I think it comes from the network module, but I've put it here because to me, those are really related. And we'll talk about what is called elastic load balancing or elastic load balancer, or if you wish, ELBs. What are elastic load balancers or ELBs? Well, those are my web servers, and they're receiving a lot of connections from the internet. How can I ensure that all those connections do not end up on the very first instance and none on the others? Well, for that, I need a load balancing mechanism. Well, that's exactly what the Elastic Load Balancer is. It is a service that will put a load balancer. So you enable that service here, the ELB service, the Elastic Load Balancer, for that fleet here. So the Elastic Load Balancer becomes your single entry point. So this is to the ELB that you will assign the public IP address. And then all the incoming connections will be load balanced automatically to all the systems that are available by the ELB. No need to do any manual load balancing. It's all done by that service. But what is great about that service? It's a fully managed service. It's not a virtual appliance. Well, in fact, it is, but not in a sense where you don't need to consider scalability. You don't need to consider high availability. What if I lose that ELB? So I need to bring in another ELB to have high availability or to scale out because there's a large demand. Well, no need to do that. It's a fully managed service by AWS. It'll scale automatically and it'll be highly available. It's built in. All right. It's fully managed by our team. You just enable that logical component and it'll do the rest for you. And this one here receives connection from the internet and load balances those. So since it receives connection from the outside, we call that a public load balancer. But what if I've got requests coming from those front-end server that I need to load balance on my back-end servers as well? Well, same thing here. You could put an Elastic Load Balancer here and do the exact same thing. But this one, in this case, is a private load balancer because it receives internal connections and redirect those internal connections, load balances those. All right. A great thing about the ELB service is that it works really tightly with the auto-scaling groups. So if the auto-scaling group spins up a new machine, it'll automatically register it with the load balancer that will then start sending connections to it. And if it shuts down an instance because of a decrease in demand, it'll automatically deregister that machine from the load balancer. You don't have to do anything. The system will do it for you. So same thing here, health check. If it kills a machine and spins a new one to replace it, it'll let the ELB know and the ELB will then point to the new machine. Pretty cool. So auto-scaling groups and elastic load balancing, two great services that can work together. You can use each and every one of those individually, but I think they are really strong when they work together, right? Because now your fleet is managed automatically, but also the workload is load balanced automatically. All right. So this is what what auto scaling and elastic load balancing, which is the next slide. This is what those services are: elastic load balancing and auto scaling. Now that we talk about elastic load balancers, know that there are three flavors of load balancers. So when you enable that service, it's going to ask you which one do you want to run. Do you want to run the application load balancer, network load balancer, or gateway load balancer? What's the difference between the three? Well, application load balancer works at the layer 7 of the OSI model. For those of you who are knowledgeable, so basically it looks at the HTTP, HTTPS requests, looks at the header, HTTP header, and evaluate a bunch of stuff. All right. So it really is made for modern web-based applications, HTTP, HTTPS based applications. All right. If what you need is something that works more at the TCP/UDP or TLS level, or if you wish, at the layer 4 of the OSI model, well, in that case, what you need is the network load balancer, right? Really robust, really optimized for spiky traffic patterns. So really good for that. And then you've got the gateway load balancer. What's the gateway load balancer? Let me just erase that because I'm going to need the place. Let me just get rid of this. Thank you. So the gateway load balancer is in a specific use case, and you'll see it makes sense. Let's say I've got requests coming from a user over the internet trying to reach a resource, which is, in that case here, my web servers, which are EC2 instances. But what I would like to do is for all my incoming traffic, I would like to monitor that traffic. I would like to analyze that traffic. Could be for security reasons, could be for compliance reasons, I don't care. But what I would like to do is use a virtual appliance that will analyze that traffic. Well, in that case, what you could do, you could use a gateway load balancer. With the gateway load balancer, it'll receive those connections. It'll receive that traffic, and then will redirect that traffic to the virtual app that will analyze it. Once it's analyzed, it'll redirect the traffic back to the gateway load balancer that can then load balance that across all EC2 instances. But by doing so, what it does, it follows a protocol. It follows a well-known methodology that basically does not affect the traffic packet. It does not transform the packet in any way. So for the end user and the application, it really is transparent. It looks like the connection came from the user directly and went to that EC2 instance, even though it actually traveled across a virtual appliance and it was analyzed. The packet stays the same due to that protocol it uses. All right. So it is in that use case that you're going to use a gateway load balancer. Otherwise, you'll simply use either a network or application load balancer. There's also another load balancer out there that I'll just mention, which is called the Classic Load Balancer. It was back in the days before Virtual Private Cloud or VPC were introduced on AWS. People were launching EC2 instances outside of a VPC, so it requires a different technology, which is the Classic Load Balancer. But it really is only for that specific scenario where you've got old EC2 instances that were never migrated to a VPC when VPC got introduced, all right? So it probably is really rare. No, Mohammed, you cannot do that with the network or application load balancer because it does not follow that protocol I was talking about and will therefore transform the packet. So the packet then for the application will look different. It'll look that it comes from that VApp. Well, it's not what we want to do here. We want to show it as if it's coming from the user, because the network or application load balancer do not use that technology, that protocol. For firewalls, we'll talk about firewalls later. Lucien, I'll answer your question. You'll see. Virtual firewalls is a different topic. It does not really apply here, although it applies, but it's not through either the load balancer nor the VApp that you would do that. Well, unless that VApp was a firewall, but we'll talk about virtual firewalls later. All right. Now, for other computing services, we've talked about Lambda, right? We've explained serverless computing charged by the millisecond, and you upload your code, you set a trigger, then once it's triggered, it's going to execute, and once it's done, it exits, and you only pay for the compute time you used. which is much better than running a virtual machine constantly just in case someone needs that piece of code. So you create a serverless microservice. Just something to remember about Lambda that I forgot to mention. A Lambda function, because that's how we call those, a Lambda function that you execute cannot last for more than 15 minutes. All right. So if your Lambda function takes more than 15 minutes to execute, then maybe you should consider something else, maybe like a container, or simply maybe breaking it down in smaller microservices. So it could be that Lambda function that does a part of the job, and then that calls another Lambda function that maybe does the rest of the job, the remaining part of that job. All right. So it depends on what that microservice does. Right. But there is a 15 minutes limit. So imagine you can run 1 million functions or 3.2 million seconds of compute time per month. That is a lot. Now, you guys have great questions, but I just thought of something. Instead of just giving you the answers, so we've talked about EC2 a lot, we've talked about Lambda. What if you want some information about those services? How do you do that? How do you find information for those services? Well, let me show you. The way we work with our website is we always use the same URL pattern. All right. So it always starts with aws.amazon.com / the common service name. So for example, if we want to have information about Elastic Compute Cloud, which is EC2, EC2 is the common name, well, simply type in /EC2. And then you can reach that services page, which is always laid out the same way. First, you've got the overview. The overview tab will give you some information about what that service is, what it does, and how it can help customers. But then you've got the features that are included in that service. And as you can see, there could be a lot of features, all right, included in that service. Then you've got the pricing tab if there is a pricing tab. So if there's a pricing tab, this means that it's a paid service. And here we will explain how you're going to be billed, how we will charge you for those services. So, for example, if I click that, we can see here, on demand, spot instances, savings plan. We've explained that, right? There's even a free tier, so you can look into that. Depending on the service that you're looking for, there could be service-related tabs. For example, for the EC2 instances, well, we need to know about the instance types. So there is a tab for that. So if I click this here, I can see the instance types, general purpose, compute optimized, memory optimized, and the letters and the resources that are available depending on the size. All right. So you get all the information there. Then you've got the frequently asked questions, the FAQs. Listen, this is where, and you can see just for EC2 instances, how many of those there are. It's unbelievable. I would say that 95% of the answers to student questions I find here under the FAQs. Those are gold mines. Then you've got the Getting Started tab, which will tell you where to go from here to learn more about that service and start using it. And then a resource tab with additional resources such as maybe customer testimonials. All right. So now you know how to fish instead of just having me give you food. All right. So whenever you've got a question about pricing, this is where I would go to find that answer. Hope this was helpful for you guys. So now let's resume with our presentation. So Lambda, yes. Talking about serverless computing, there's another service that is available, well, a couple of services available out there, and those are around what we call containers or containerized applications. You guys are familiar with containers? Do you know what containers are? And if so, what are the two flavors out there? Two flavors of containers out there? Yes, Docker and Kubernetes. Absolutely. Yes. You guys are good. Awesome. So you are experienced with containers. So for those of you who are unfamiliar with containers, let me explain what those are. And you'll see it makes a lot of sense. It's a pretty cool technology. So when we talk about virtualization and virtual machines, remember, let me just make sure that I've got my pen. So I've got a physical server. And then on that physical server, there's hardware. Then there's the hypervisor. And on that, I run a virtual machine that has virtual hardware. That also has an operating system and then applications. We get the idea. But that virtual machine, you still got to maintain the operating system. Of course, if you need to scale, you can easily scale by spinning up another virtual machine and then another one and so on and so forth. But what if you've got a fleet of 100 virtual machines? That means you've got 100 operating systems to take care of, to maintain, to update. That's a pain. But also, what if you are installing an application on that virtual machine that uses a certain version of Java? And then later on, you install, let's say, another application that requires a different version of Java. Can you actually run two versions of Java on the same system, on the same virtual machine? Absolutely. You can do it. Is it easy? God, no. It's a pain. It is a nightmare. I've done it multiple times in my life. What's going to happen? You can multi-instance Java, but your application will always end up pointing to the wrong instance of Java. You're going to run into compatibility issues. It's going to be a nightmare. So what happened over the years is that somebody that was tired of maintaining large fleets of operating systems and dealing with compatibility issues for applications because they require different libraries, different binaries, well, they invented what we call containerized applications or containers. How does that work? Well, you've got the same physical server. On that physical server, there's hardware. And on that hardware, we install an operating system that allows you to run containers. So it's kind of an hypervisor, but that hypervisor allows you to run containers. And what's a container? Well, a container is basically an application, and it's just the code, just the application, but it also includes all the binaries and the libraries that are required by the application. And when it runs in its own container. And that container is isolated. So it does not interact with other applications outside of that container. It can, but what I mean is you will not run into a compatibility issue, because what if that's app one? Now I need to run a second app 2. And this one has different binaries and libraries. Well, we don't care, because now this will run in its own container. So it will not be impacted by app 1. So you can run different applications with totally different binaries and library requirements. And if you need to scale, you simply add additional containers. So that's pretty cool, because now you no longer have to deal with compatibility issues, but also you don't need to maintain operating systems anymore, because this part here, the physical layer, as well as the operating system, all managed by AWS. You don't need to manage any of that. You simply deal with your containers. Now, I'm not a container expert, but let me explain to you something that I know a bit. The person that invented those containers, those containerized applications, that led to the first flavor, which is Docker, which basically is something that allows you to create containerized applications, right? However, the problem with that is that Docker was not made to manage large fleets of containers. And over the years, customers liked it so much that environments became larger and larger and fleets became larger and larger. What if you've got to manage dozens of hosts with hundreds of containers, or hundreds of hosts with thousands of containers? Well, in that case, because they were lacking orchestration tools, exactly, Joe, they invented something else, which is called Kubernetes. And Kubernetes provides all the orchestration tools you need to manage larger fleets. So this is why you can have either a Docker or Kubernetes image. And in both cases, if you want to run that on AWS, we do have a service for that. And it is called Elastic Container Service, or ECS. ECS. This one is for Docker containers. And this one here, EKS, which is not really, that's wrong. It's Elastic Kubernetes Service. So Elastic Kubernetes Service, EKS, is of course made for Kubernetes containers. But this will allow you to deploy those containers on AWS and manage the clusters and orchestration of those containers using your traditional Docker or Kubernetes tools, management tools and orchestration tools, because it is fully integrated. It is exactly the same as if you were running a on-premises container environment, but now you're running it on AWS Cloud, and the hardware is fully managed by AWS. You just need to manage your containers, the clusters, and the orchestration of it. So it is a partially managed service, if you wish, because you still got to manage the clustering and orchestration of those. What if your customer does not require that much control? They don't care. Some customers do. They want to have full control. That's perfect for them. But what if, in their case, they prefer something that is more fully managed, where they would like to just upload their containers and publish those, and that's it? Don't want to manage the clustering, the orchestration of all that. Well, introducing AWS Fargate. AWS Fargate allows you to run ECS and EKS containers. But this time, it's in a fully managed service. It has auto-scaling capabilities. It does the whole thing for you. You just need to publish your containers and you're done. All right, so it depends. It's another of those solutions or use case where you have more than one solution. Remember my database example? Well, that's something similar here as well. It really depends on your customer, what they want to do. Suaz, first, I don't have that information. And second, I would not like to get in great details about that, because that would be too time consuming. However, I'm going to copy the question, and if I can find some information, I will share in the follow-up email. I'll try to see. All right. So we're done with compute services. That's the longest segment, compute, because this is an important topic. Now let's get into the second most important topic, storage, because storage is important as well. So for storage services on AWS, we've got three options, basically. Those three options are S3. Well, there's one that is not listed here because it's not covered in that course, but it's covered in the Cloud Practitioner Essentials course. So we've got S3 storage, which is our object storage. We've got EBS, Elastic Block Store, which is our block storage service. And there's another one as well, which is not there, which is file storage, which is EFS, Elastic File Storage. Let me explain what's the difference. All right. So let's begin with, I think, the storage technology that you are the most familiar with. We've been using that technology for decades now, where are we going to write data as blocks on a block storage. So any type of disk that is attached to a server, so your laptop has a disk, well, that's block storage. A LUN that you carve off a SAN storage unit and that you present to a server, physical or virtual, well, that's block storage. All right. And what happens with block storage is that when you write data, let's say I'm going to write a 2 gigabyte file, it writes that data as blocks. So it's going to break down that 2 gigabyte file into smaller blocks. And the huge advantage of that is that block file system that is attached to an EC2 instance, for example, so we're going to attach that to an EC2 instance. If I modify that file, even slightly, let's say just a few kilobytes, well, it does not rewrite the whole thing. It only writes the modified blocks, which makes it really performant. So performant that we can use it for, of course, boot and root volumes for our EC2 instances. We can use that to install applications and store application data. Think about SAP, Exchange, SharePoint. Those are a good example. But also, it can be used for database volumes. So your database files could be stored on EBS, Elastic Block Store. So an EBS volume is presented to an EC2 instance, and you will see it at the operating system level. So you'll need to go and format the volume. You'll need to create a file system, and then you can use it. It can scale. It can scale. So for example, you've assigned 100 gigs. It's being saturated. Well, you can easily modify and expand it to store more data. And that can be done on the fly without even shutting down the virtual machine or the application. And you can expand the volume. I demo that in the CPE course. All right. So, but it is only attached to one EC2 instance. If you shut it down or you terminate the instance, the good news is that volume is persistent, which means it'll still live. It's going to stay around. So you can then attach it to another EC2 instance if you want to. But it can only be attached to one EC2 instance at a time. One EC2 instance could be attached to more than one volume, could have actually 2 volumes attached or more. We don't care. But a volume can only be attached to one and only one single EC2 instance. Keep that in mind. If you need to present storage to more than one system, one EC2 instance, well, in that case, what you'll need is that other service that is not covered in this course, which is file storage. File storage allows you to file storage, which in our case is called Elastic File System or EFS. So this will allow you to create a volume that you can then attach to several EC2 instances. So you can create a shared file system. So for that, you'll need file storage. It also is block storage, but presented differently. In this case, it's going to be an NFS share presented to your Linux machines, or it's going to be using SMB for Windows machines. All right? But that's what you would need. That's the difference between EBS and EFS. EFS can be shared amongst multiple systems, while EBS cannot. It's only one system at a time. Yes, you are correct. You are correct. So we'll need 2 EBS volumes if you want your EC2 instance to have 2 volumes. Absolutely. You are correct on that. All right. Very good. Very good point there. All right. That's for block storage. But there's also another pretty cool service that is heavily used on AWS, which is called Amazon Simple Storage Service, or S3. All right. S3 is object storage. Object storage is quite different. It's not block storage at all. It's different. First, it's not even a volume that you present to an EC2 instance. It actually is a storage type that you access using the web. You access that using HTTP or HTTPS. And you can upload data into your S3 bucket. That data is not written as blocks. It's written as an object. So let's take that 2 gigabyte file example that I used earlier on. So it's going to be written as a 2 gigabyte object. And then to that object, there's going to be metadata that will be added to it, as well as an ID key to reference the object and its version. So this makes the object, the way it is written. So if I was to modify that object even slightly, it would rewrite the whole thing, that 2 gigabyte. So obviously, you can see that it's not good to install applications in there or store database files in there. Again, it's not even a volume that you present to an EC2 instance. It's good for those type of data, that type of data that you plan on writing once and rarely modify, but from which you can read many at high performances. That's what it was built for. So for example, in there, you can easily store static content such as videos, images. So when we're talking about Netflix movies, when we're talking about Amazon Prime videos, we're talking S3. This is where it's stored. All right. Could be website images, could be application files, but here, let's say a file stores some data somewhere and it needs a location to store that data, could be there. But again, not data that you plan on constantly modifying, because that was not built for that. Could be even web pages, actually. You could host an entire static website on S3 without having a web server of some sort. You simply enable the function on S3 and boom, there you go. You just published a website. Pretty cool. You just point to the main page and you're done. Very, very cool. So it's good for application file hosting, for backup and disaster recovery. Yes. So you could easily send your backups there. So if you need to recover that data, it's available on S3. You don't plan on modifying that data constantly, but if need be, you can recover that data. You can read from it. So it's cheaper than EBS. So that's why a lot of customers are relying on S3 for all those use cases, because it's cheaper than EBS. As soon as we're talking data lakes, data warehouses, awesome for that. And again, streaming data, all those movies or videos could easily be stored there. All right. So when you choose S3 storage, a little like EC2 instances, there are things you may configure, you may define, and one of them is the storage class to use, because S3 has several storage classes. All right. One of those storage classes is made for active data, and it is called S3 standard. S3 standard is made for active data. Why do we say that? Because you got to understand how you are being charged for the use of S3 storage. When you use S3 storage, first thing to understand, the upload process doesn't cost a dime. All right. So even if you were to upload 10,000 terabytes, you won't be charged a dime for the upload process. Let's go with 10 terabytes. However, that space you'll take, that 10 terabytes, you're going to be charged for that. And also, when you download that data or move it out of the region, and that's important, out of the region. So for example, if you download 5 gigs back on premises, you're going to be charged for that 5 gigs. If you replicate that 10 terabytes to another region, that means a copy of the data leaves the region. You're going to be charged for that transfer between the regions. Be aware of that. Okay, so you're going to be charged when the data leaves the region. An EC2 instance, part of the same region that would access that data, no charge at all, because it stays in the same region. But as soon as it is accessed, it is leaving the region, you're going to be charged for that. And why do we say it's for active data? Because you're going to be charged a bit more for the storage space you use, but you're going to be charged less for the download process, because we know it's your active data. You'll use that data a lot more frequently. So that's why it was built for that. So you're going to be charged a bit more for the storage space, but a bit less for the download process. All right. This data is replicated across 3 AZs, 3 availability zones by default. You don't need to do anything. It's replicated within the same region, so it's not breaching any compliance, but there's at least 3 copies of that data that is made across several availability zones, which provides you with 11 nines of durability. So 99 point. So you've got 99.99999% chances that if you click to access a file, you'll have access to that file. I never did the math, but one of my students once told me that this represents basically that you're going to lose access to a file for 4 seconds every 10,000 years. That's what we claim. Don't know if it's the truth, if it's the real math or not. I didn't do it, but that's what that student said. But then you've got additional storage classes. There are 2 that are for infrequently accessed data. Why? Again, because the way you are being built. So that one here, standard infrequent access, or standard IA, as we call it, standard IA, well, provides the same 11 nines of durability because it's replicated across 3 AZs. We're all good there. However, and the upload process still doesn't cost a dime. We all know about that. But now, the 10 terabytes of storage space will cost you less than this guy here. Why is it costing you less? Because we're going to charge you a bit more, however, on the download piece. But we don't care because it's made for infrequently accessed data. So we know that you don't plan on frequently access that data, but you still need to store it. So we wanted to make sure that storing the data will cost you less. However, accessing it when needed will cost you a bit more. So again, ideal for maybe some type of backups. Or think about compliance data. So they ask you to keep data for 7 years, for 10 years, just in case you are being audited. Well, all right, so let's use that. All right, you want to see 5 gigs? Which one? Okay, those? All right, so I'm gonna show those to you. So you're gonna be charged a bit more for that 5 gigs that you access, but it's not frequent. It's just when you are audited. So that's a very good use case for that. There's another one here, one zone infrequent access, which will cost you for that 10 terabytes even less than this guy here. But the download will cost you the same thing. Same thing as this guy here. Well, how come then do you charge me even less than this one? How can you achieve that? Well, quite simple. As the name implies, that data does not get replicated across multiple availability zones. You still have more than one copy across several data centers, but it's all part of the same availability zone, the same AZ. So that's why it's one zone, infrequent access. That's why it costs you less. But you cannot put all type of data there. It should be data that you can recreate, because what if you were to lose the entire AZ? You're going to lose access to that data. So maybe data that you can recreate. But that's a very good use case for that type of storage class. And then, last but not least, we've got our 2 archive data storage classes, which are called S3 Glacier and S3 Glacier Deep Archive. So these guys here, well, let's take Glacier. Glacier will cost you even less, significantly less, than these guys to store 10 terabytes. Wow, that's great. Especially when you deal with archive data that you need to keep for long term, but you don't want to pay much for that. That's perfect for that. However, the downside is, reason why it's significantly cheaper, it's because you do not have instant access to the data. What if you need 5 gigs out of that 10 terabytes? Well, first, what you got to do is initiate a recovery of that 5 gigs back into S3 standard. And only when that data is in S3 standard will you be able to access that data. And yes, Paul, one AZ, that's what I meant for one zone infrequent access storage class, absolutely. So yes, you got to initiate the restore first. So you don't have instant access. And how long does it take to restore the data? Well, it depends on the retrieval tier that you've picked. And there's a different price tag for each. It could be either bulk, could be standard, or it could be expedited. So if you go with bulk, can take up to 12 hours to recover the data. Standard, up to 5 hours to recover the data. And expedited, 1 to 5 minutes to recover the data. So as you can see, you don't have instant access, which means you cannot store any type of data there. You cannot store, let's say, critical data. If you need to rebuild a server, you need to recover data from that. Well, that's going to take time because you first need to initiate a restore to S3 standard, and only then can you recover it on the server. However, back to my compliance example. They ask you to keep data for 10 years. You really don't want to pay much for that. And if I'm being audited, all right, you want to see those 5 gigs? All right, come back later today or come back tomorrow. That data is going to be recovered and you'll have access to it. You see, the SLA is different in that case, not the same as a critical server that you need to rebuild. All right, so really important to evaluate the type of data. And there's another one, Glacier Deep Archive, even cheaper than Glacier. God, it's cheap. I use it for my personal backups. My wife is really into family videos. We've got terabytes worth of raw family videos. Actually, I've got over 17 terabytes, all backed up to Glacier Deep Archive. It doesn't cost much per month to store that. Really cheap. However, again, retrieval is not instant. And in this case, for Glacier Deep Archive, only to bulk and standard. And standard, up to 12 hours, while bulk, up to 48 hours. So I know if I want to recover that data, I first need to recover that data into S3 standard, and it could take up to 48 hours. But those are family videos. I don't care if I've got a drive that dies on me here. I could simply recover on a new drive by first recovering the data into S3 standard. Well, redundancy. Again, this one here still provides you redundancy, but not across several AZs. So this one here, we've got 9 nines, so 2 less nines compared to the other one, but still a lot of durability. Don't get me wrong, there are several copies across different data centers. So it depends on you got to analyze your data, but if you really want that 11 nines, standard IA is your best bet for sure. But again, it's for infrequently accessed data. So if you plan on accessing that data on a regular basis, Paul, that's going to actually cost you more than if you were to use S3 standard, because you'll incur so many charges to access the data that at the end, it still is more costly actually than S3 standard. Durability, Natalia. Now, when you use those storage classes and you define where you want to upload your data, or what you could do, you could even create what we call lifecycle policies. So you could start analyzing your data and say, well, listen, when that data has not been accessed for more than that long, you can then move it to standard IA. And then if it hasn't been accessed for even longer, then you can move it to Glacier. You can do things like that and create policies. Or what you could do even better, you could use a service called Amazon S3 Intelligent Tiering. So you choose it as if it was a storage class, but it's not a storage class actually. Actually, in this service, you can enable up to 4 storage classes. And what the system will do, it'll analyze the data for you. It'll use artificial intelligence and machine learning, and will analyze the data for you. It'll start moving data around for you. It'll make the best use of all storage classes possible to save you the most money. So data that is infrequently accessed will be moved to standard IA and then later on to Glacier and maybe deep archive, Glacier deep archive, all done automatically. And if you need to access data, the system will move the data back. Don't need to do anything. It'll do it for you. And the cool thing about that is that Amazon S3 intelligent tiering has a cost. It's a small fee based on the thousand of objects it monitors and moves around. But the cool thing is it does not incur any cost to move data between tiers. Even if it comes back from Glacier to S3 standard, you will not be charged for any of the retrieval tier costs because those are kind of included into your S3 intelligent tiering costs, which are minimal. So just enabling this will save you a bundle right there because it'll intelligently analyze your data for you and make the best use of all storage classes. Pretty cool stuff. All right, and we've explained storage, one zone IA, Glacier Deep Archive. All right, one more minute before we get to the break. Let me show you a solution here that will be built mainly on S3. So that's going to be our main service on which our solution is built. But as I told you, no matter how great a service is, no matter how great S3 is, what makes that solution even better is the fact that we're going to use a combination of services to achieve a goal, to meet a need. So in this case here, we will create a data lake because S3 is very popular to create data lakes. What are data lakes? It's a central location in which you're going to dump a bunch of structured and unstructured data, and then from which you'll be able to analyze and process and do a lot of things and get the most out of your data. So, for example, we could create an S3 bucket in which we're going to store the data and then use AWS Lake Formation to create a data lake. Once you've created your data lake, then it's time to ingest the data. And to ingest the data, there are several services available. That data could come from a database, either on AWS Cloud or on premises. And for that, we could use the database migration service to grab the data and then store it into S3. Or if the data is on premises or coming from an application that runs, it's data that is analyzed on the fly. Well, we could use Kinesis for that. If that data is on premises and we need to move it over, we could use AWS Direct Connect to create a direct connection between your data center and AWS Cloud. Or if there's even too much data to do that, well, you could use maybe Snowball, which is a device that gets shipped to you on which you copy over the data and then ship back to AWS that will then connect it to your AWS environment so that you can copy the data into S3. So you can see that we can use several services to ingest the data. Once the data has been ingested, then we can process and analyze that data using a bunch of services such as Amazon Athena, which will allow you to run kind of or analyze different types of data in S3. QuickSight that will kind of create a relationship between all those types of data. And then maybe Redshift to create a data warehouse. And then once the data has been analyzed, you need a catalog and provide search capabilities to your users. So in that case, you could use DynamoDB, which is our non-relational database service, which could contain your catalog for that data. And then you could use Amazon Elasticsearch to allow users to run searches against that data. But in order to do so, you need to ensure that only the right users are accessing that environment. So for that, you need to provide user access and user interfaces. So for example, you could use maybe in identity and access management to configure security to ensure only the users that are allowed will use the system. Or if you want to use an external authentication mechanism such as Facebook, well, you could use Amazon Cognito. Once that data, once you provided access to the right users, there might still be personal identifiable information or PII stored in that data. So you need to protect that sensitive information. So for that, maybe configuring encryption and manage the keys through our key management service. And maybe use CloudTrail to monitor each access to that data using those keys. And also use CloudWatch, our monitoring service, for that as well. So as you can see here, we've got an entire fairly complex solution that is built mainly on S3, but still S3 alone does not suffice. We need additional services to build a full solution that will meet the customer's need. All right? So that's just another example for you solution architects. All right. Next will be the networking services. But before that, we're going to take 25 minutes for lunch, and then we will resume with